Hello, good morning everyone. Till now, we have discussed about the various software engineering practices, and under this we discussed the various principles, right? The principle at each and every phase. We have discussed, till now we have discussed the three principles, right? We have discussed the principles. We have discussed about the software engineering practice, communication practice, and the planning practice, right? And inside each and every practice we are discussing the various principles. Now we will see the analysis modeling, right? Now we will see this modeling. See, in this slide you can check this modeling, right? What is our first step? Our first step is the communication, second is the planning, right? Then modeling, construction and deployment. We also call it CPMCD, right? Inside this modeling we are having again two subphases, say analysis and the design, right? See, why modeling is required? When we create a model, right? When we create a model, our aim is to get the better understanding. What is our aim? Our aim is to get the better understanding about the problem, right? Any problem is given to you, what we will do, we will model it in a way that we can get a clearer view of that problem, right? And make sure when you are making a model, that model must be capable of representing the information, right? It must capable to represent the information that software transforms. Whatever the model you are making, whatever the software you are making, it should able to transfer the information, right? So please note it down. The information is the first point. Second, the architecture and the functions that enable the transformation to occur. It means when you are making a model, the information is important, architecture of your model is important, and the function that will enable your transformation to occur, it is also important, right? And also the feature that the user desires and the behavior of the system which takes when you perform the transformation, right? So our aim is to create a model that can be easily understood by the next people or the person working in the next phase. And in this we are having three important points, that is the information, right? How that information will flow from one place to another place, right? Architecture of your model, what is the basic architecture of it, and again the functions of it. Okay, so basically what we can say, in the analysis model we are having three different domains, right? We are talking about analysis only. We will see in detail, we are talking about analysis. In this analysis, when you perform the analysis task, you will focus on three different domains. First is the information domain, second is the function and its behavior. Got it? You will focus on this. Or when we are able to represent or focus on these domains, your analysis model will be easily able to represent the customer requirement. You can easily represent the requirement of the customer. Okay. So we are having principles associated with this analysis model. Those are very easy. See, first one is the information domain of the problem. It means the data that flows in and out of the system. Got it? The data which flows in and out of the system. In and out of the system means what? Suppose we are having this system, right? This is indicating your system. So in and out means whenever you will give some input to it, right, you will get some output from here. Okay. So the information domain of a problem, it must be represented and understood. The data that flows in and out of your system. It indicates your system. You should be very clear that which information will pass from here and what you will get as an output. Okay, when you are performing the analysis task. So, see, the information domain, it encompasses the data that flow into the system. If when we are saying that the system, the data, it should be flow into the system, so who will pass that information? The data may be passed from the end user, from the other system, or it may be from other external devices also, right? And the data flow out of the system. How it can come out of the system? See, we are saying into the system. So into the system means what? You can also pass the information, you can use any device and you can use the other system. When you are saying it will come out, it may come out via the user interface, network interface, right? You can also see some graphical output. It might be like it is generating some report, right? So in this way, whenever you are talking about the analysis model, your first principle is the information domain of the problem, right? The flow in and out of the information. Got it? And the information will go in, it may go in by you, system or any device. And when it will come out, how you can see it? You can see it with the help of report, with the help of a graph, or via network. You can see it, or by using any other interface. Got it? So this is our first principle. And we have discussed earlier in the analysis model, we are having three different domains. First is the information domain. Now second was the function, right? The function that the software performs, it must be defined, right? See, why? Because the software function provides the direct benefit to the end user, and it also provides the internal support for those features that are user visible. Okay? Some functions, it transforms the data that flow into the system. Also sometimes we are having a function, right? I have designed a system and it will pass only the even value. So I have written the function that I am giving the number from 1 to 100, but in place of passing all the number, it will only pass the even number to the system, or the odd number to the system, or the addition of those number, or any other series which you can identify from it. Okay, so this way we can say some functions transform the data that flow into the system. Okay. Third is the behavior of the software, right? The behavior of the software must be represented. So all the 3 points are covered: information, function and the behavior. Okay, see, the behavior of any computer system is driven by its interaction with the external environment. How I will identify your behavior also. If I want to identify the behavior of any student, how I will identify? I will identify how you are behaving with the others, how you are communicating with the others, what is your behavior in the external environment, right? So the behavior of a computer system is driven by its interaction with the external environment. Okay, and also the input provided by the end user, control data provided by any external system, or any monitoring the data which is collected over a network. It all cause the software to behave in a specific way. We are saying that it's affected by the external environment. So external environment means what? External environment means the input may be provided by your end user, right? We can have some control data that is provided by any, say we said we have designed a function, where we are only passing the even values. So some controlled data is provided by any system, or we are also monitoring the data by taking it as an input. So these are all the things that will specify the behavior of your system, right? Fourth point is, see, the model that depict information, function and the behavior, it must be partitioned in a manner that uncovers detail in a layer or hierarchical fashion. Right. It means whenever you are developing a system and you are performing an analysis of it and you are following all the principles, it means you are focusing on information, you are focusing on functions, you are also focusing on behavior. But you will not represent all the thing together. Got it? You will try to represent it in the form of layer. It means first layer, we will see the multiple models are there to represent that layered information. Layered information means we will represent one thing here. Now we will move here. Here we will represent some other thing, like some more detailed description of it. Right. And again we are going to the next layer. Here we are again representing some description. Okay. So this way you try to represent the behavior in an hierarchical manner. Okay, your fourth point is the analysis task should move from essential information towards the implementation detail. Okay, see, if you see the analysis model, right, your analysis model, it begins by, how it begins? It begins by describing the problem. It begins by describing the problem from user perspective. Okay? From the user perspective, the essence of the problem which we are trying to solve is described without any consideration of how a solution will be implemented. Okay? When you are performing the analysis, you will never give any hint, you will not think about how it is going to be implemented. You will do that task at the time of designing. Got it? You will just give the information that how user will interact with it. Got it? You are going to perform this function. This is the behavior of your system. This information will go inside, this information will come outside, but you will not say how it would be implemented, how you are going to implement it. So this is all about the analysis modeling. Just remember 3 points you will never forget if you are talking about the analysis. You are doing the analysis of your system: information, function and the behavior. The 3 points are very important. And then obviously if you have all the things in place of explaining it together, you try to explain it with the help of different layers. Okay? And also one more point is, when you are talking about the analysis, in place of giving the implementation detail, we will only focus about the information. Got it? So this is all about the analysis principle. Just take this example. See, you can see here in this example we are saying information is flowing, right? You can see the information flow. Suppose this is your system, this is a small part of your system, this is a billing department, right? The information is passed by that customer. Might be possible that a customer is using some algorithm in his mind. Yes, I will pass only this information to billing department, I will pass only this information to the account department, right? So again this is passed by the someone, it is stored by the someone, like it is collected by someone else in the form of sales order. So this overall you can say this is representing the analysis. Here analysis model, here we are not implementing anything, we are just given an idea that he is the person, he is going to pass the information. There is some system is there, in that system some functions are written, right? And also how you will check its behavior, like how it is giving the output, how it behaves with the external environment, whether you can use the output created by the other system easily or not. So this is like how the information will flow and what you will represent in the analysis. See, we will learn lot of diagrams, right? You will also do some practical examples with this. You can see here one thing is written, that is the UML diagram. You call it a UML diagram. UML is a language, unified modeling language, not a programming language. Got it? It is not a programming language, and this picture is taken from the umldiagram.org. Right? So this way we will try to represent our analysis. Okay, this is one more example. Here also what we are doing, as we discussed, you can take the information from the user, from any device or any other external system. Here what you are doing, you are taking the information with the help of the device called sensors. Right? Here you are taking the information, you are performing some operations, say processing the data, then on the basis of that data you are taking some decision, you are merging both the data, then you are keeping it on your local database, and then after keeping it on local database, you are keeping it in a cloud server. Okay, right? You are sending it to the global database or the cloud server. Got it? And also, like, see, you can see here the bidirectional arrow might be possible. Sometimes we also need the information from here. In place of keeping it in your local system, you are putting it on a global system. You will take the information from here, then again you will process further. Right? So you can see here all the arrows. These arrows are representing the flow of information, and how that information is processed. It is processing with the help of some functions. You can say some decision modules are there. Right? Definitely there will be some methods how to process the data. Got it? So this is all about the information, function and the behavior of your system when you are designing any software. Got it? So this is related with your analysis. Again, second is the designing part. Right? As we discussed, in the analysis part, we try to represent the customer requirement with the help of the model. Okay? And in designing the model, we provide a concrete specification. Got it? And try to understand. If you want, you can also note this point. Design model, it provide a concrete specification for the construction of your software. Right? It will provide the specification, each step by step detail, that how you will implement your system. Okay. So design model will represent the characteristic of the software that help practitioner to construct it effectively. Got it? To construct it effectively as by designing by the architecture, the user interface or the component level designs. Okay. So again we are having some principles associated with this. Okay. Just right. The design should be traceable to the analysis model. Got it? We know what analysis model does. So the design model basically it translates this information into an architecture. Got it? Whatever the information flow we were discussed, or in your software the information will flow, here the design model will translate this information into an architecture, or what you can say, architecture means a set of subsystems that implement major functions, a set of component level designs, right? So this way, whatever the design you are doing, again we are having some models. Again some model comes under this category, how you will represent the designing, right? The very the most known thing to all of you, I think all of you know this term, that is the class, right? Class diagram. Diagram you don't know, but you know about the class, right? In object oriented programming we use one term, that is the class. So in the designing part, we make the design, how we represent the designing, we make the class model. We will use the class model, right? We will learn everything how to make the class model. So this way your design should be traceable to the analysis model. Second is, always consider the software architecture of the system to be built, right? See, Software architecture is what? Basically it is the skeleton of the system which you are going to build, right? It affects this architecture. It affects the user interfaces, it affects data structure, it also affects program control flow and the behavior and the manner in which testing can be conducted, right? Also the maintainability of your system, resultant system, and much more. For all of the reasons, because it is associated with this data structure, user interface, flow of your system, your behavior of your system, the manner in which you will perform the testing, design should start with architectural considerations, right? So whenever you design the architecture, keep in mind that it is a skeleton of the system which you are going to build. After design, again we have the next part, say construction. These both, the model, design and the analysis model, comes under modeling task. It is a sub part of the modeling. It is not the part of the construction. Got it? So next point is, design of data is as important as design of functions. Okay. Why we are saying this? See, the manner in which the data objects are realized within the design, right? You have to specify each and everything, that how that data is going to be used. Not only the function designing is important. Function means, suppose you have simple written, yes, my system is going to perform the billing operation. Okay, but how that data will go, right? What is the type of that data? From which function you will pass the data? Which function is going to use that data? What it will return it? Whether it will return only the integer part? You will not say like this every time when you are going to buy any, say suppose you are going to buy a shirt. So it is not possible every time the cost of the shirt is 799 or something. Might be possible it is like 745 and 50. So you have to be clear and you have to define each and everything, what will be the output of that data, not only the function, right? So design of data is also as important as the processing the functions. Fourth is interfaces. Both the external and internal interface must be designed with care, as we discussed in the information domain. And if you remember, in that information domain, what we were doing, we were passing the information, right? What we were doing, we were passing the information, right? Data flow in and data flow out. And we discussed, when you will pass the information, that information will be passed, it may be passed with the help of user, device and all. So when you are passing the information, definitely there will be some interface, right? There will be some interface. Got it? So how, like, you will design that interface? So like, take proper care when you are designing the interface, right? One more point is, see, the manner in which data flows between the component of the system has much to do with processing efficiency, error propagation and design simplicity, right? And what is the benefit of designing this interface in a, like, with a very care? A well designed interface, it makes integration, remember this point, integration easier, and assist the tester in validating the component functions. Got it? So when you make the interfaces, please keep in mind that it is going to help you in the integration of different sub component of your system. Fourth is user interface design. User interface design should be tuned to the need of the end user and should stress ease of use, right? See, it should, in every case, it should stress ease of use. The user interface is the visible, right? User interface is visible manifestation of the software, right? See, no matter how complicated its internal function, right? How comprehensive its data structure, right? No matter how well designed its architecture, a poor interface design, it leads to the perception that your software is bad. Got it? Just simple example is, suppose you are using any website, and if that website is not like that much familiar to all of us, it is creating a lot of issues how to use that website and all. So what you will say, you will say यार अच्छा सॉफ्टवेयर नहीं बनाया, it is not like easy to use, we are not able to understand properly, input दिया तो it is taking too much time, we are not getting from where to give input, from where to see the output and all. Got it? So whenever you perform this design task, you should keep in mind this point. Sixth is component level design should be functionally independent. Component level design means, as we discussed earlier, in place of representing your information, function and the behavior together, we will try to represent in the form of layer or the component, right? Or the different small subsystems. So keep in mind, when you design this small component, small function, there should be very less relationships, right? It means you can understand in this way also. Suppose you have this one function, right? This is your one function of your system. Similarly, you are having another function, right? You are having another function of your system. So there should be very less dependency between them, two functions. You can pass the information from one function to other, but it's okay. But it should be not like that. When I am performing this, it is dependent on this. Got it? You can give in and out, but not the dependency. So they should be dependent. It means they should be independent. Independent means whatever the information you are writing, whatever the data you are writing, all of the data, all the used data is having very high bound. Bound means very high connection within a function, not outside the function. It indicates the high cohesion, right? The function should have the high cohesion, means the relationship within the components, right? High cohesion. Second is, the components should be loosely coupled to one another and to the external environment. It means this arrow indicates the loosely coupled, right? It is also called the coupling. Low coupling and the high cohesion is very important feature in designing. Sometimes the question also comes. Explain it with the help of any real life example. So high cohesion means, if you are designing a function, so all the components, they should be related within this, right? They should have the relation between this, a strong foundation, dependency within this, but not outside this. Okay? It should be loosely coupled with other or to the external environment. It means just giving an information, no dependency on the other people. This indicates the low coupling. Designing represents model should be easily understandable, right? See, basically, why we are saying this 8 point, the purpose of a design is to communicate information to practitioner, right? To communicate information to practitioner who is going to generate the code, right? Who will generate the code, who will test the software, and also to others who may maintain the software in the future. So if your design is difficult, right? If your design is difficult, it will not serve as an effective communication medium. That's why it should be easy, because so many people are there. Like, one, by using this design, one will code it. By using this design, other will test. Also by using same design, other will maintain the software. So it should be easy. It should be easy. Designing should be very easy. The design should be developed iteratively, right? The design should be developed iteratively. With each iteration, the designer should strive for greater simplicity. At each and every time, if you are performing the multiple, if you are going to the multiple rounds, it means you are performing the same thing multiple times. So at each and every time, it should go to simpler and simpler. Got it? See, all creative activities, design occurs iteratively. Okay? It means the first iteration work to refine the design and correct error. Okay? But later iteration should strive to make the design as simple as possible. Okay? So, when you properly apply these designing principles, the software engineer or you can create a design that exhibits both external and internal quality factors, right? So external factors are what? Those properties that can be readily observed, okay? And the internal quality factors are those properties that lead to high quality design from a technical perspective, right? So when you are following all the principles, right, all the principles, you create a design that will exhibit both internal and external quality software. Got it? So this is all about modeling. This is all about the modeling part. Inside the modeling part, we discussed about both the principles, modeling principle and design principle. Just take this example. There is one example, right? See, in this, basically what we said, in place of solving the problem, right, in place of solving the problem together, we will try to solve that problem by dividing it into a multiple parts. Also, okay? Again, you will make the multiple modules, it means multiple functions. You will follow some layered approach, and also what we will do, we are saying whenever we are making the interface should be very easy. It should be very attractive, easy to use. We are not worried about its internal details. So when you perform the designing task, keep in mind all those points. Okay. Now the construction and the deployment. We will discuss this in the next class. If you have any doubt, you can mail me, right? Or you can also schedule a meeting so we can discuss your queries. Thank you.